Two and a Half Admins, episode 33. I'm Joe.
I'm Jim.
And I'm Alan.
Let's do some news then. And the first is that Victoria University of Wellington, their IT department, made a slight mistake and managed to delete a lot of files on people's desktop PCs.
I always get tripped up by these mundane details. So the short version is they basically nuked everybody's profile directory on their local computers while trying to reclaim space from inactive user accounts. And we don't have a ton of detail from inside the university about this, but based on the sound of it, my guess is that they really only intended this to run, against their network file servers. But Active Directory group policy is a very powerful tool. And if you aren't careful with how you scope it, you can exert that power in ways you did not intend to. My best guess is they didn't have proper scope controls on a group policy that they deployed to delete all files belonging to older user accounts. And what they did instead was delete all the files pretty much on everybody's user account, and not only on the network file servers, but on every desktop joined to the domain as well. So what you had is you had faculty, you had staff, you had students all turning on their computer to discover that they could log on, but it was like the first time they had ever logged on to it. And everything was nice and shiny new, and all their files were gone.
Apparently somebody lost their PhD thesis because they only had one copy on their desktop, which seems like a bad idea to begin with.
At least email it to yourself. Come on.
Something.
Like, how big is a thesis file going to be? Like, even with a bunch of images and stuff, like a few megabytes.
I think it was a PhD undergrad, so it could have been massive with accompanying, data.
Oh, okay, right, fair enough.
We really don't know, and that's kind of not the point.
Yeah, one computer is not a good place. And then, they also mentioned that network drives is like, it does seem like the school should back up the network drives, but in the end...
No. The school absolutely did back up the network drives. Okay. Everything that was stored on their mapped drives was restored almost immediately because, of course, it was network file servers and the university was actually backing those up. But the odds that a university is just going to have... I'm laughing even trying to say this. The odds that a university is going to be backing up the C drives on tens of thousands of student, faculty, and staff desktop PCs, like, that's not going to happen. That's just not going to be a thing. So if the only place you saved it was on your C drive, then when it's gone from your C drive, it's gone.
Well, except that it's not, right? Because it's not actually deleted. You can use NTFS recover. I can't remember the tool, but there are definitely tools to recover deleted files.
Yeah, there are definitely tools, maybe. And in a lot of cases, people were able to bring their PCs into the university IT department. And in some cases, they were able to use undeletion utilities to recover them. There are a few problems with that. Now you've got literally tens of thousands of people who probably need a department of maybe 50 techs, and they need them all at once to run these undelete utilities for unspecified amounts of files that if you've ever used one of those, there's metadata missing. Like, the entire file name isn't even present. You're kind of guessing at whether the file you're undeleting is what you want in a lot of cases. It's ugly.
Yeah, it's not like the old FAT32 where it just changed the first letter of the file name to an underscore or whatever to make it deleted. NTFS is a lot different. And you can only recover the file if not a lot of data has been written to the drive since you deleted it.
Not just that, we haven't gotten to the most fun part yet. Hey, Joe, how does trim work on SSDs?
Yeah, true. Because I've actually done this before. I deleted a directory or a folder, I guess, off an NTFS drive, realized immediately what I'd done and managed to recover it completely in full. So it is possible, but yeah, I hadn't done much. I knew that I needed to not write anything to that drive, whereas I suppose that's not going to be the case. Because that's what I wanted to ask you about. If with this Active Directory thing, like, to what extent does it wipe the SSD when it's doing that?
So the file system does the trim just once you delete the data, it eventually, usually with a small delay, just for batching, tells the SSD, I'm not using these sectors anymore. And then the SSD based on its firmware, might decide to overwrite that with zeros or to deprogram that cell or whatever.
But whether it does that or not, you're not going to be able to get any more because you never have access to the actual physical mapping of media underneath the firmware layer on the SSD. You only have access to what it tells you the virtual sector that you ask for is. So once the SSD says that virtual sector is no longer mapped to this media, it's gone as far as you're concerned. You're not getting that back.
Yeah. The first big difference with SSDs is that the sector number in the file system or the device presented to the operating system doesn't map to a physical place on disk like it does in a hard drive. A hard drive, it can actually end up somewhere different when you replace a bad sector or whatever. The drive has some spare sectors to replace those with, but has a short list of what those might be. In an SSD, it's all indirected, where every sector could actually be somewhere else, and where it is can change without having to tell the file system, which is the main point of SSDs, is being able to do the wear leveling. That cell's wearing out. I'm going to move that data over here, so I just update my little index that says fake sector X is actually real sector Y. And the only guarantee trim gives you is that after it's been trimmed, reading it will return zeros. It doesn't mean the data is necessarily going to be destroyed. It's right. Trim is not secure erase. It might be destroyed or it might not, but it's been flagged as that's gone now. And so you can't get the data back with a normal just reading those sectors, because the firmware in the SSD specifically is programmed to say, I'm supposed to return zeros for anything that's been trimmed.
You might very well be able to send that SSD, after trim has been implemented. You might be able to send that to like Gilware or Drive Savers, and they might be able to recover that data using forensic recovery techniques, but those are going to begin at $800. That is as cheap as it can possibly get, and it may not be that cheap. If you've never used one of those services, the way it works is you ship them your drive and they figure out how much they're going to charge you for the service. And then you say either no, send me that back, or destroy it, whatever, or yes, I'll pay you the money. But the money will not be less than $800. And that's as of like 10 years ago. The minimum may be higher now. Due to my profession, I almost never use those places because, like, if I have to use a drive recovery service, that means I didn't do my job as a sysadmin and, keeping the data safe to begin with. I only actually touch those once in a blue moon when I inherit a customer that has already gotten something terribly screwed up, and it's screwed up so badly and the data is so valuable as to, make it worth spending thousands of dollars recovering it. Maybe.
So how did this university get into this situation where all of the students and faculty had machines that weren't properly backed up? How does that happen?
Because you don't back up the machines, right? The whole point is everybody should put their files they want to keep on the network drive, and we back up the file server. Mm-hmm. We're not going to reach out and back up 10,000 machines that have who knows what gobbledygook on them.
That aren't always connected.
But you're not even going to set them up with OneDrive or whatever, which smacks you in the face every time you turn on a Windows 10 PC.
They did have OneDrive, and, the folks that had saved data to OneDrive, that data could be recovered afterwards. But not everybody was using OneDrive.
Yeah, like when I was at college, it was very clear what was backed up and what wasn't, and that you don't save stuff on your local PC because if something's wrong, they're going to bring a different PC and replace it and go and fix that one. They're not going to fix your computer in place. They're going to swap it. And so that's the whole point of having a profile that lives on the network, is you can just sit down at any computer at the school, log in with your username and password, and have access to your stuff. Your email, all the stuff lives on the network.
Forgive my ignorance here, but is my documents and, the default paths, is that not set to the network drive then?
So it can be. It can be, but there are serious problems with doing that. The amount of network load that you generate is enormous. When I attended the University of South Carolina, they had roaming profiles on all their machines, and basically every system was completely unusable for about 2 weeks every September when the new, horde of freshmen came in, because the system would be trying to synchronize roaming profiles for, like 7,000 or 8,000 new students all at once. And you literally couldn't even save a file. Like, you would log into a lab computer and you could log in, but when you would go to file and save on, like a Microsoft Word menu, it would just lock up there, because part of that operation is it wants to read your user directory, and it can't, because it is just completely locked up, saturated. There are no resources. So you can't even actually save to your C drive outside there because the default location is in your user directory, which is inaccessible because the whole system is just crushed under this load of 6,000 new profiles. I don't blame them at all for not having all this data automatically synced to the network drives. If you waved a magic wand and made me king of the university network, I wouldn't do roaming profiles for everybody because it's just nuts.
What would you do then? Surely there's got to be some training for people.
Yes, there should absolutely be training.
In Windows, if you look in your user directory, there's actually split your profile into 3 parts. There's the local data, which means that's where Firefox and your browser puts like its cache, because you don't want to save that to the network. And that if you go to a different computer, you don't expect that to be there. But your bookmarks, you do. And so there's, I think it's local, roaming, and roaming low, which is the stuff you need even if you're on like a bandwidth constrained connection.
Although the super fun thing, you don't even necessarily have to have a roaming profile to have your user directory set to the server. You can actually just relocate where percent user percent goes. But the fun thing about that is when you use Microsoft's just standard, I want to relocate, the location of my documents, it also puts all of the temporary cache directories on that network file server. So all the little, crappy churn from you browsing the internet and all the, bajillions of little JPEGs and CSS style sheets and everything else, all that crap goes back and forth across the network.
Well, it's supposed to be why they have the local and roaming part of the profile split, is that the crap's supposed to stay in the local one that doesn't go on the network. But
supposed to is loaded words, Alan.
If you just change the location of the user directory, then yes, you will have the problem you described.
Guess how many Windows applications love to just save things in my documents and not use that big directory structure?
Yeah.
It's a mess.
Yeah. But yeah, if you have a giant fleet of computers, backing up every one of them doesn't even make sense. Because it's going to be a lot of duplicate stuff, and most of it's stuff you're not going to care about, right? You don't back up the applications you have installed on 10,000 computers. You make the computers disposable.
Yeah.
And you say anything that's not disposable lives over here on the network, and then you back that up.
And in some university environments, they carry that to more of an extreme. They deal with the fact that you're not backing up the C drive and, the user training difficulties by just wiping the C drive constantly. I've seen university environments where the profile is nuked every time you log out. If you didn't save your stuff on the network drive where you're supposed to save it, it's already just gone, and nobody will help you with that. No, you didn't do the thing you're supposed to. In some cases, they'll actually have a message on the desktop. Your desktop wallpaper will be this profile will be wiped when you log out. Save on the H drive.
Okay, this episode is sponsored by Linode. Go to linode.com/2.5 to get started with $100 free credit and 60 days to use it. Linode offers cloud computing solutions in data centers all over the world. Whether it's scalable VMs with a choice of major distros or one-click apps and stacks, dedicated CPU and high RAM instances, block and object storage, or cloud firewalls and DDoS protection, Linode has everything you need for your personal projects right up to managed enterprise infrastructure. I recently moved my website over to Linode and it was really straightforward. And when I needed a Mumble server for our Late Night Linux community meetups, spinning up a new VM for that was an absolute breeze. Everything's been running flawlessly since I set it up, and I love the peace of mind I get from the automatic backups. So go to linode.com/2.5, get your $100 credit, and check out Linode's great cloud hosting services and first-class always available support. That's linode.com/2.5. So, Alan, you linked us to a PDF, the root server operator's statement on DNS encryption. Now, I'm afraid this was rather moonspeak to me, so you're going to have to explain it to me.
So, DNS works backwards from the root. So, for example, when you want to go look up joeres.com or www.joeres.com, the first thing the DNS has to do is talk to the root server, the dot at the very end of the domain name, and find out where the server for .com is. And after it asks the root, hey, where's .com? It says it's over here at VeriSign. And then you ask VeriSign, hey, what servers have the DNS for joeres.com? And they say, oh, it's over here at hosting provider. And then you ask them, hey, what IP address is www.joeres.com? And you get an answer of what the IP address is. And so the root DNS is basically the dot part at the very, very end of a domain name, because we looked them up backwards, right? The www.joeres.com, www is the least specific or the most specific part, and then joeres is less specific and com is less specific, and then dot is the root. And so the root is basically has the list of where all the valid top-level domains are. So .com, .net, .uk, .ca, etc., and all the newfangled weird-ass ones. If you remember, it was also the one getting all the traffic when Google was like, we'll try 5 made-up names to make sure that it's not lying to us all the time. Remember, it was a couple of weeks ago we talked about their traffic getting cut by more than half when Google finally stopped horsing around. So lately, there's been more and more of this push for DNS privacy and being like, hey, well, let's encrypt all the DNS. The problem is right now, in normal DNS, there's no encryption. You send a UDP packet saying, what's the IP address for this, or what's the next step in the chain to get to this? And the other side gets that packet and sends a reply. Or the packet gets lost and it doesn't reply, and your computer just tries again after a second or two. The nice thing for the DNS server operators about that is that they don't have to remember anything. Right? There's no state. It doesn't have to remember, with a normal TCP connection, you have the typical set of the 3-way handshake, and you're negotiating a session and standing it up and remembering it. Or if you're doing any kind of encryption, you're going to have a session key, right? Every different connection is going to be encrypted with a different key so that nobody can decrypt all those connections. But it means the root server would have to maintain all this state about everybody that's in the process of asking a DNS question. Whereas right now, they don't have to do that. They just get questions and send answers. And they don't have to know any information that's specific to who's asking. But this encryption stuff would impose all of this extra overhead and make the root servers more susceptible to a denial of service attack that could take down all of DNS. And in the end, I don't know that encryption to the root is actually that useful. There's 2 main parts to this. The first one is authenticity. You want to prove that the answer you got is actually the legitimate answer. And then the other one is you don't want other people to know what websites you're going to. We already have DNSSEC, although it's kind of icky, but whatever, to make sure that you're not getting lies instead of real answers. But for the privacy bit, the root probably makes little sense because it only contains the answers for basically referring you to the servers for .com or .net or .horse. And so there's not much privacy to be lost there. And more importantly, your computer never talks to the root directly. Your computer talks to a recursive resolver, which goes and does that for you, and is mostly going to aggregate so many other people that it's not a big worry, right? If you have the encryption between you and the recursive resolver, it doesn't really matter that the recursive resolver is talking to the root without encryption.
I don't necessarily know that I would agree on the lack of need for encryption all the way to the root. That's easy for us to say where we live, but imagine that you live in a small and repressive regime that might be super interested to know which of their citizens are resolving like .cn or, .uk or .ru domains.
Right, but if you're talking encrypted to the recursive resolver, if the recursive resolver doesn't talk encrypted to the root, your query is still mixed in there with everybody else talking to that recursive resolver. And if you're using one you trust, then it's less of a big deal. More importantly, the recursive resolver isn't going to talk to the root for every lookup, right? Once it knows where .cn is, it's going to remember that for like a day and a half.
But is your recursive resolver also going to potentially be under the thumb of the actual regime that you're worried about to begin with?
Well, then whether or not you have encryption, they already know what you're looking up. You've already lost. Is the problem, right? That's why you would use Quad 9 recursive resolver or something that isn't under their control and do it with encryption. So you know you're talking to the real Quad 9, not a fake one, and that nobody's reading the query.
The thing is, you're basically making the argument that all of the encryption is kind of unnecessary because you're either getting out from under your regime or you're not. I'm not sure that I buy the argument that like, well, it doesn't matter if anybody knows the top level domain you resolved as long as they don't know the rest underneath it. Like, yeah, it's less sensitive, but I think it's maybe a little reductive to just make the decision that that's not sensitive information. It could be.
In this case, my point is more that the trade-off of the risk of increasing the complexity of the root isn't worth not knowing that little bit of data, because your recursive resolver could instead just zone transfer the root once a day and then have those answers handy without ever having to disclose anything to somebody sniffing what the recursive is talking to. Like the root contains information that doesn't change very much, right? It's just the delegation of who controls .com versus who controls .org.
Okay, but let's say that you live in the United Arab Emirates, where there's to the best of my knowledge, it's a capital punishment for being gay, and you wanted to go to a literal .gay site. There might be very few people in your country who are doing that. That zone might not normally be getting transferred by ISPs. And if the government can tell...
But sorry, the zone I'm talking about transferring is literally the dot zone.
Right.
You would get the answer for .com and .gay mixed together in such a way that you wouldn't be able to tell what one... Or because it's not provoked by a query, it's provoked by a cron job, you can't make any assumptions about what's actually being looked at. If you install bind or any resolver, most of them actually contain a root hints file.
Yeah.
I mean, that they don't actually have to go and talk to the root anyway.
Yeah, that's true.
But, it doesn't solve the problem of the .com server, right? VeriSign's servers that are the root for .com.
Right.
Then yes, you have the problem of that needs to be encrypted, and how do we do that in a way that isn't terrible? And that's why VeriSign sponsored all that work on TCP fast open to be able to try to have TCP connections, but when you're frequently talking to the same DNS server, we don't do the full three-way handshake every time to try to get down that latency and get back to something closer like what we have with UDP. But yeah, I don't know what the answer is, but I agree with the root people that the root is too sensitive to risk making it too susceptible to new denial of service attacks by making them carry all this extra state for mostly static information that's all public knowledge. And they're not saying we're never going to do it. We're saying we'd like to see it mature and the middle level operators deal with it before we risk the root of all DNS on some people's half-baked protocols for trying to increase privacy.
Okay, this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Let's do some free consulting then. You can send your questions in for Jim and Alan to show@2.5admins.com. And thank you everyone who is supporting us on PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. So, Chris writes to us, I run a number of services from my home server that are internet-facing. I understand that the smart and best practice is to minimize that as much as possible, but some of them I want access to while away from home, and some are used by family members across the country, so it's unavoidable at some level. My question is this: how do I know if a service's authentication and login page is hardened enough to raw dog it on the open internet? Some services like Plex and Nextcloud I'm pretty confident about, but others like BookSonic and BabyBuddy I have less faith in. I even asked the maintainer of BabyBuddy, which uses Django, about this, and he gave me a pretty non-committal, I think it should be fine. So I thought I'd run it by you guys. Is there a better way to go about this while maintaining easy login access for other APIs and my 70-year-old parents 1,000 miles away?
The first answer, how do I know if a service's authentication or login page is hardened enough to raw dog it on the open internet? That's an easy answer. No, it isn't. I don't care what it is. It's not. That includes, services like Plex and Nextcloud do not expose common login interfaces over the internet that lead directly into your home. That's just a terrible idea. What is a much better idea is just set up WireGuard. One way or another, you don't want to rely on somebody's authentication and login page just exposed to the internet in general, because you're probably not going to know when there is a vulnerability and when all of a sudden an automated worm is just scouring the internet looking for that and owning your crap. So you protect yourself by wrapping another layer of authentication. The easiest way to do that is set up WireGuard. WireGuard is not going to make it hard for your 70-year-old parents 1,100 miles away, because you set that up for them as well. And, whether it's on their laptop or, their phone or their tablet or whatever, you can set it up where it's just automatically always on, and it gives them access over the secure encrypted tunnel into your network. And from there, they can hit your login page. And the only people that you're exposing that interface to are the people who are allowed to use it in the first place.
The other solution I was going to recommend specifically for things like web services is you can put them behind an Nginx. So what I do for a bunch of these is, so our Nginx faces the internet, and it has HTTP basic authentication turned on over HTTPS with a Let's Encrypt certificate. And you log in with a username and password. It might be just one for everybody, or it could be separate ones or whatever. And then you can then load the normal login page for the stuff. So like at my company, we use it to just protect the wiki and the source repository and a bunch of other things that you would browse to. You have to log in over HTTP basic over HTTPS first, and then you get the normal login pages and so on. And so it's just Nginx reverse proxying to the next cloud and the thing and the other thing. And it works nicely enough. The pop-up box in your browser for the username and password is easy for other people to understand, but it just means you're protecting that, Nextcloud or BabyBuddy login page from people scanning it and finding it. And you can also do things like implement rate limiting. Say, you can't try more than 5 times a second to log in. Because the main problem with something like BabyBuddy is, even if they built it nicely, if it doesn't have that back-off mechanism, then somebody can just try 1,000 passwords a second until they get a password that works.
Or just try 1,000 times a second and use up all your bandwidth, and you can't do anything because it's all going to this brute force attempt.
Yes, or just use up all the CPU in the Django application or whatever, and you just can't ever use the application.
The HTTP basic trick that Alan is talking about, I do that on my own web services on actual, no kidding, internet services hosted in the cloud. Like I use the Roundcube webmail application for my own email services.
And that's had enough vulnerabilities over the years that it just makes more sense to put it behind basic.
Exactly. I don't expose its authentication directly to the internet, even though in theory it is supposed to be hardened enough. Every once in a while there's a vulnerability, so you've got to get through HTTP basic authentication first. It just throws up, a little challenge, and it on mine it literally says authenticate or be shot, just kind of because that's who I am. And it's just a homie code. Like there's just one username and password that gets you through that. And there are actually, 50 plus people who need access to that particular set of services. But we've all just got the one username and password, because all it really is like worm repellent. Like if you don't actually know how to get in, you're not going to be able to probe to look for that vulnerability, because all you're going to see is just Apache HTTP auth. And the other thing about that is that it's more reliable, the HTTP or Nginx implementation of HTTP basic auth, because it's just so freaking simple. There's nothing fancy going on. There's no federated this. There's no theming to make it look pretty. It is literally just a thing that's like, you need to put in the password if you want to get in. And that is all that piece of code does. But again, while all this is an option, WireGuard is by far the better one, and it's probably going to be the easier one for you to set up, because you don't have to learn how to do all the funny little Apache or Nginx tricks and potentially reverse proxying and all that. You can literally just set up a simple WireGuard config, and you and your parents and your spouse and your friend have a key and nobody else does, and it just works. And
it avoids the problem of having to have them remember that there are 2 usernames and passwords, and they're not maybe the same. And yeah, that can be confusing. Like Jim said, in most of the setups I've done of this, there's one username and password to get there, and then you get a login page where everybody has their own username.
This also protects you from, your parents who insist on having just completely stupid passwords. So, when your dad just absolutely insists that, my password is a perfectly adequate password, you may not be able to train him out of that, but if it's wrapped behind, a WireGuard key required to get to it, then it's not really going to matter so much anymore.
For my grandfather, it was always the youngest grandchild's name, which often was not nearly long enough.
Hunter 2.
All right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your emails and questions. You can find me on Twitter @Joe Rissington.
I'm at JRSSNet.
And I'm at Alan Jude.
We'll see you next week.